That bit better? Cool. So we made it then, last session. You had fun 2 days? Or 3 days for some of you? So this talk does have quite a lot of overlap with the keynote, but it's taking the stuff in a different direction. So in the keynote I talked more about modularity and how to create systems that were modular. This talk really explores the diagramming aspects and how we can make sure there's a nice clean match between architecture and code. Who has diagrams on their walls at work here? Do they match the code? Sometimes not really. So this is one of the things I mentioned. I do see lots of organizations who have diagrams and they don't match the code. And they don't match the code for a number of different reasons, and some of them we'll look at shortly. This talk is also about answering this type of question. So can someone tell me some tools to draw pictures with that's not Visio? Omnigraffle, yeah, Omnigraffle is essentially the same sort of tool though. So this is one of the other questions that we're going to answer here. So I thought I was not going to have to do my intro to Jersey, given the whole intro I did during the keynote, but I met some people last night and I said, hi, I'm from Jersey, and they said, yeah, I worked in New York for a bit. I'm like, really? So I'm from Jersey, that Jersey down there. It's a tiny island off the coast of France. If this was interactive, we could pinch to zoom in. Jersey gets bigger, we pinch to zoom in again. There we go, there's Jersey for you. And I worked in London for about 12 years for software development consulting companies. And most of the stuff I was doing was building Java systems for banks, media companies, insurance companies, that sort of thing. Across lots and lots of different areas of Java, client server, desktop, web stuff, SOA, messaging, whatever. And I moved back to Jersey in 2008, as I said, because it's just a nice place to live. The stuff I've been doing over the past few years has really been focusing on helping teams understand architecture. And this is from a number of different perspectives. I had a bunch of questions asked after my keynote yesterday about how do we do architecture in an agile setting. And that's certainly a lot of the stuff I help with. And the short answer is you need to do just enough. And by just enough, I really mean you need to focus on understanding the structure of what you're building and also identifying and mitigating the highest priority risks. So I take a risk-driven approach to architecture. And that basically simply answers the how do you do upfront thinking in an agile setting. A lot of the other stuff I do is I work with teams and I help them visualize and understand the systems that they have. And a lot of this is through software architecture sketching workshops where we'll get them to visualize what they think their system looks like, and then we kind of do a comparison with the code and see where it differs. And I think it's great that software architecture is coming back into fashion again. Architecture was definitely seen as a horrible thing a number of years ago, even until fairly recently. And I'm seeing more and more people interested in architecture. I'm seeing more and more people interested in, stepping back to see what their system looks like from a high-level perspective. So that's great. I'm going to plug my books again. Definitely the one on the right we're going to talk much more about today. So if you do go to Pubg, find the slider to 0. All the stuff I'm going to talk about today is in the book. The thing I didn't mention yesterday is that I still write code. So in addition to doing these kind of jetting around the world and doing workshops and conference talks, I still write code. And I think this is really important because a lot of architects have lost that connection with the stuff they're building. They've lost that connection with the code. As I said briefly yesterday, for me, architecture and coding are just two sides of the same thing. And in order to understand one, you need to understand the other, and vice versa, of course. So this talk is essentially about the intersection between these two worlds, and more specifically, how we can get these two worlds to match up a bit better than they normally have in the past. So let's look at the tension between these two worlds first, and let's see what has pushed them apart historically. As I said yesterday, you probably remember my sad ass joke, right? I'm a big fan of diagrams. I'm a big fan of visualizing the structure of a software system to better be able to communicate it. And that's really where I start a lot of these stories. So how do we best communicate architecture? And I talked about abstraction. You know, you inherit that huge big code base, it's 100,000, 200,000 Java classes. You don't draw a class diagram. Drawing a class diagram is probably the most dumbest place to start because the cognitive load is just too high. There's far too much information. So what we do is we clump our stuff together into modules, components, services, subsystems, and it's those things that we talk about when we're having these architecture discussions. And these things help us essentially reduce the cognitive load. So if I'm sitting in front of a million-line code base and somebody says, what does this class do? I could guess if it's named properly, but I might not have any idea. If they say, what does the authentication module do? It's a far easier thing to reason about in my head. So it's really about creating a smaller number of abstractions that we use to understand a big complex system. This is a quote from Philip Crichton's 4+1 architectural view model. So there are lots and lots of different ways we can think about and describe software, specifically from a kind of architecture perspective. The 4+1 model was created back in the late 90s when Philip Crichton was working for Rational, and he was part of the kind of Rational Unified Process team. And it basically says to describe a software architecture, we use a model composed of multiple views or perspectives. And this really gave rise to when I'm thinking about my software system, I need to look at it from different angles. Sometimes I'm interested in security, sometimes I'm interested in deployment, sometimes I'm a developer interested in the code. Has anybody used the 4+1 model before? Is anybody still using 4+1? No, yeah, it's one of those things. It was quite popular at the time, and people are still using many of the same concepts, but they're not necessarily using the 4+1 model. So this is the 4+1 model, and basically it's four architectural views of a system, kind of glued together with a bunch of use cases or scenarios. So the logical view in the top left corner is really it's a kind of abstract view of the functionality provided by the system broken up into a set of modules or components. So this is like your authentication module, your logging module, maybe your booking module, your customer module. It's really a decomposition of the functionality into functional blocks. That's normally how this view is kind of realized. The development view is specifically targeted at software developers, and it's basically how do we realize the stuff in the logical view as code. When this came out, OO was still relatively new. Some of the diagrams you see will be using the Booch notation, but essentially it's things like class diagrams, layer diagrams, and so on and so forth. The process view is not about business process, which is kind of confusing. The process view is about how do we take the stuff in these top two views and turn them into processes that run on machines. And it's really about talking about separate things that are running, the exchange of messages between these separate things, and also concurrency aspects. And the final one, the physical view, is really about infrastructure. And more specifically, how do we take the processes and deploy them onto our infrastructure? So that's the 4+1 model. This is great, but if you read Philip Crichton's paper, the semantics around the views is very, very clear. Unfortunately, lots of people have misinterpreted this model, and when you go onto someone like Stack Overflow and say, how do you apply 4+1 to a Java project, you get a totally different set of answers. And it's because there's no real specific guidance and advice here. It's just a set of views to represent a software system. Of course, that's not the only way we can do this. Some friends of mine, Owen Woods and Nick Rozansky, they're based in London, they wrote a book called Software Systems Architecture, now in its second edition, and they have something called Viewpoints and Perspectives. And essentially what they did was they took Philip Crichton's 4+1 model and extended it. And this is the seven viewpoints that make up their viewpoint catalog. The context viewpoint is really how does your software system fit into the rest of your world, your environment. The functional viewpoint is actually the logical view from the Philip Crichton model, but Owen and Nick renamed it because they thought logical view sounds a bit fluffy. So they wanted to say this represents the function, the functionality at a high level. Information viewpoint talks about information and data. The concurrency viewpoint is kind of similar to the Philip Crichton process view, and it's talking about processes and concurrency. Development viewpoint matches almost one-to-one with Philip Crichton's. Deployment, operational, kind of map onto the physical view. So again, you can see some similarities, but they've added some additional information. The big problem here, of course, is the names have changed. So if you're familiar with 4+1 and you move to something like the Woodson-Rosansky model, you now have to get your head around the different names. And of course, I've only shown you 2 examples. There are countless other examples out there if you start reading architecture books. And this is where it starts to get really confusing. So if I'm talking about a development view, do I mean a view of the code? High-level design? Some people might actually call that an implementation view. But of course, the word implementation for other people means the installation and rollout to a live environment. So there's lots and lots of ambiguity that sort of creeps into this whole way of thinking. So one of the things you do need to do as a team is you need to agree upon how you're going to describe your software. All of that stuff aside, the thing I really find fascinating about all of these view catalogs is that the logical view of the system, right, the high-level breakdown of modules or functional blocks, is almost always separated from the development view. This is kind of weird. I don't know why this happens. I think it's because, architects traditionally want to know a very high-level picture of what the system does and how things are, or how responsibilities are partitioned across the system, whereas developers want that low-level view of how the code implements that stuff. And actually, maybe this separation between the logical and the development views mirrors the kind of traditional handoff we used to see in waterfall environments, where I might be an architect, I draw a bunch of logical pictures, they look fantastic to me, I give them to a team, they do something else. So maybe there's something about this handoff which is surfaced in these models. Google doesn't help. If you go and ask Uncle Google what a software architecture diagram looks like, you'll get pages of stuff. And it's just page after page after page of pretty Visio-style block pictures, isn't it? There are some UML diagrams in here. The 4+1 model does crop up here occasionally. But Google basically doesn't help, and it tells you to draw pictures like this. And whenever I go around organizations and I kind of nose through their wikis and their documents, this is what I see. This picture in the middle is fairly typical. I'm not going to have my old rant about layers again, but lots of architecture diagrams have layers in. That's probably an important way to think about systems from some degree. We have lots of boxes. Sometimes some lines gluing these things together, but most of these diagrams attack architecture from a logical perspective, don't they? You'll see very few tech choices on a lot of these diagrams, and these diagrams are definitely architecture or marketecture diagrams. They're very high level. Let's unwind a couple of steps here. So imagine I have a blank sheet of paper or a blank whiteboard, and somebody gives me some requirements for a system, and they ask me to go do some design. I'm going to sketch up a bunch of architecture diagrams. And one of the questions I want to answer with these diagrams is essentially this. Given this collection of diagrams that have been generated during an upfront design exercise, are the diagrams reflective of the thing I think we want to build as a team? That's really one of my primary questions that diagrams seek to answer. And if I'm drawing diagrams with a team retrospectively based upon their code base, then it's kind of flipped on its head. So here's a code base, here are some diagrams. Do the diagrams reflect what we actually have in the code, what we built? I said this yesterday. I strongly do believe that we kind of fail to have a common, consistent set of abstractions. And I'm going to use the word component again. So for some people, component means, the web application is a component of our entire system. And for others, a component is something running inside that web app. And we do this over and over again. And I've heard teams use the same term in the same meeting, and they're referring to totally different levels of abstraction. The funny thing is, they're totally oblivious to it. They don't realize that other people are using the same words to mean a different thing, because their mind's just not switched onto it. Right, quick poll, because I can do a poll because I can see the audience today. Who uses UML here as a part of their day job? 1, 2, 3, 4, 5. That's it. 5. What's everybody else doing? Are you not drawing diagrams, or are you just using boxes and arrows? There's lots of, boxes and arrows nodding going on. Yeah. Maybe some cylinders. Maybe a cloud if it's web scale. I've been quite fortunate to kind of jet around the world a lot in the past few years. And I've asked this question absolutely everywhere because it's really funny. I've been to half of Europe. I've been to the US a bunch of times. Australia. I was in China 3 weeks ago, which was fantastic. I've been to the Middle East. About 9 out of 10 people don't seem to use UML. So it's normally like 10% of people raise their hands. I think this is optimistic, to be fair. There's also some cultural variation here. So if you ever go to the Netherlands or Germany, there's a much higher percentage in the Netherlands and Germany who use UML. I don't know why. They just do. I also went to an architecture conference in London, and they were mostly kind of enterprise architects, and 50% of the audience raised their hand. I'm like, no, you're lying. You guys do not draw any diagrams whatsoever. Put your hands down. I'm also starting to see lots more audiences where 0 people raise their hands. And I think, the UML is now on its death spiral. Some of the universities, certainly in Europe, are not teaching UML. Organizations are not seeking people with UML skills. And, imagine we're on a team of like 20 people and I'm the only person who knows UML. Well, I've got 2 choices. I can either educate the entirety of the team, which costs me lots of time and money, or we just do something else. So UML's got, there's a lot of good stuff in UML, but it's fading out of fashion very quickly. So I do use UML, but I only use UML very sparingly, and I only use UML for documenting some of the lower level aspects of my system. Class diagrams are useful, but only if you're showing a small part of the system, like a small component or something. Sequence collaboration diagrams are useful, whether you're mapping out interactions between classes or components. State charts, activity diagrams are nice because they're kind of flow charts, and that's pretty much it. How many diagram types does UML 2.4, 2.5 have? Like 20? I use 5. No idea what the rest do. Don't need them. Let me fix this problem. When I'm specifically looking at architecture diagrams and try to create a brand new notation, because a lot of people don't use UML because they're scared by the notation. You're on a whiteboard, you draw a class diagram, some bright spark decides to draw a diamond, and then they shade the diamond, and that gets like 20 minutes of discussion about, is that really composition or aggregation? The other half of the team then have to go to Wikipedia to look up what the difference between aggregation and composition is. So it's just too detailed. I'm a big fan of creating a common set of abstractions, but actually letting the notation we use evolve naturally. And this is kind of counter to what UML has tried to do, and it's also counter to what you'll find in the building industry, and also things like electrical engineering. If you've ever seen a schematic of like electrical circuit or circuit board, You know, a resistor and a capacitor and a switch all have very specific, well-known, standardized symbols. And although I think as a software industry we should get to that, I don't think we're mature enough to do that yet. So let's fix the abstraction problem first, and let's do the notation later. If this sounds a bit foolish, let's go and get two maps of Atlanta and lay them out side by side. The two maps of Atlanta will show the same things, won't they? The same abstractions. The MARTA lines, you know, this place, the Georgia aquarium, the various districts and the malls and the points and sites of interest. So although the two maps are showing the same things, they might be using a slightly different notation. Shading might be different, colors might be different, the line styles might be different. How do we lock the notation? Well, there's a key in the corner. There's a key in the corner that describes the notation we're seeing on this picture. So a map is a really, really nice example of a self-describing piece of documentation. And that's a really nice concept we can take to software diagrams. So one of the things I tried to do, and I explained this briefly yesterday, is I really want to create a set of maps for my software system. You've probably seen this yourself, you know, you join a new team, they say, here's 100,000, 200,000 lines of Java code, grab a coffee, knock yourself out. It's like me coming to Atlanta for the first time, being taken in a taxi to my hotel, and then somebody says, right, you have to get to the Georgia World Congress Center for 9 a.m. tomorrow, but you're not allowed to look at maps and you're not allowed to use public transport. I'll just end up walking up and down every single street, exploring until I find something of interest. That's essentially what we ask our developers to do when we dump them in, you know, hundreds of thousands of lines of Java code. So what I want to do is I want to use a map. I want to fire on my iPhone and I want to say, right, I'm here, where's the Congress Center? Okay, now I know where I want to go. And these maps need to be at different levels of detail, different levels of abstraction. So this is the model I walked through briefly yesterday, and I want to again in slightly more detail. So the abstractions I think about are a way to describe the static structure of a software system. And it starts with the software system as being like the key thing. And when we zoom down to the next level, basically my system is made up of containers. I should probably point out that I came up with this terminology before Docker took the word container, which is kind of annoying, but there's a definite relationship between what I would think of as a container and something that could be run in a Docker container. So, you know, a container could be a web app in this case, and a web app could run in isolation in a Docker container. A container in this case could be a database which could run in its own Docker container. So there's a definite parity here. These are just things like web apps, mobile apps, download apps. They're things that run and things that store data like, you know, S3 buckets, file systems, databases. You zoom in, those things are made up of components. Bunch of related stuff, nice clean interface, we're done. And because I mostly write systems in Java, my components are made from classes. If you're dealing with a functional language like Haskell or F#, well, you classes, and you might not have components either. So what I would do is I take this approach and map it onto the language that you're using. So with F#, for example, it's not components and classes, it's modules and functions. With JavaScript, it's modules and objects. With something like a database technology, maybe it's components and tables, views, stored procedures. So essentially, this bottom level is the code. It's a reflection of the code, which we can then aggregate into these larger building blocks that I'm going to call components, but you might want to call modules. What I'm trying to do here is basically create a static structure. So this is a static structure first approach to describe a software system. And it's the static structure from the very top level, the software system, down to the code essentially, with a couple of extra layers in between. And once you understand the static structure of your software system, you can start to describe other facets of your system really simply. So for example, imagine we have a feature or a use case or a complex user story that we want to describe how it works to somebody. I could draw a sequence or collaboration diagram based upon things in my static model interacting. Those things could be classes, or they could be components. Well, just because you're using a UML style notation, there's nothing to stop you kind of abusing it slightly to make more sense. Show how you are deploying your system. Well, if you have a map of your infrastructure, your servers, your firewalls, your routers, the deployment mapping is simply how you spray containers onto your infrastructure. So again, getting the static structure stuff done first helps with everything else. This is the stuff I skipped over. So once you have this way of thinking about your software system, you can then draw these diagrams very simply at each level in turn. And this is what I call my C4 model. And it stands for context, containers, components, and classes. If you want to make it a bit more abstract, context, containers, components, and code. And I'll start with a system context diagram, just to set the scene. I'll then show the containers inside the system. That's the next level. We then zoom into the interesting containers, not all of them necessarily, but the interesting containers to show the components inside it. Or, I actually normally stop at this third level. Especially when I'm doing an upfront design, or even retrospectively diagramming an existing system, I don't normally find the need to go any deeper than this. Also, that this next level can take a long time. But if you want to go there, then you can draw class diagrams of, your component implementation details, for example. I'm not saying you should only draw these C4 type pictures, because of course, as illustrated by Philip Cruikshank and Owen Woods and Nick Rosansky, there are lots of different ways we might want to think about our software system. UI mock-ups and wireframes definitely tell you something you can't get from the static structural diagrams. If you have a complex domain model, that's often not reflected in the architecture diagrams because it's kind of buried down in the depths somewhere. To collaboration diagrams showing things interacting. Maybe workflow diagrams and business processes. That's a different aspect altogether. Structured deployment, so on. I do recommend reading those two resources. So if you want to think about other ways to describe software system, these are really, really good starting points. One of the things I've come to realize over the past few years is that actually the most important stakeholders of architecture is us as developers, because we are the people that have to live with the architecture all the time. So the way I approach a lot of my software architecture, and particularly the diagramming and the visualization stuff, is from a software developer perspective first. And that's why lots of my architecture diagrams look technical, because they are technical diagrams. They're technical diagrams predominantly aimed at me as a developer, of course. So this is the diagram I showed you yesterday, and it's for my little Tech Tribes content aggregator. It's all open source, it's all on GitHub. It's basically Java, Spring, MySQL, Mongo. So this is my context diagram. That thing in the middle is the system I built. There are different types of users at the top. So to explain this a bit more clearly now, if you go onto the site now, if you open up your browser and go to techtribes.je, you see an anonymous user, and you can view the content on the site. Because my content is aggregated into the site, I can sign in with my Twitter ID and manage my user profile. And there's that admin user I talked about yesterday. So that's my user community. I'm choosing to represent these people as roles, but you could do actors, personas, or even real people. Boxes at the bottom are my key system dependencies. So what do I need to have access to so that my system actually works? In this case, we're pulling data from Twitter, GitHub, and we're subscribing to blogs. So this is a really, really nice, simple diagram that you can show to non-technical people, business people, or even a developer on the first day of joining your project team. It's just something to kind of set the scene and provide some context. the interesting thing about the context picture is if you go back to Owen Woods and Nick Rosansky's first edition of their book, they didn't have that context viewpoint. And what was really interesting there is that they didn't have the context viewpoint because they just assumed that people on the team would understand the context of what they were building. And it turns out this isn't the case. And I'll give you a really, really good example. I did some consulting for a company in the UK a couple of years ago. And they've got this system that's been going for 20 years. It's a big Microsoft client-server system running against Oracle. And they've got lots of documentation, but it's all kind of buried on their wiki. And as a developer turning up to this organization, basically you have to read the entire wiki to understand what the system is and how it works. So I said, well, why don't we get together, have a workshop, and draw a context diagram of your system. Normally this thing takes like half an hour to draw maximum. We were there for 3.5 hours. And it turns out this one system actually talks to 38 other systems in the organization. And not one person on the team could even name half of them. So this whole context picture was like a journey of discovery. It was really, really interesting. Zoom down one level, and we get to the container diagram. And this is basically the high-level building blocks. This is the web app, the content updater, the thing that reaches out to Twitter, GitHub, blogs, pulls the data back, and I've got some data storage containers in the middle. MySQL, Mongo, and a file system. This diagram doesn't tell you anything about clustering, sharding, availability, resilience, security. That's why you need an infrastructure and a deployment view, so you can show those things separately to the static structure. We zoom into the content updater, we get the component diagram. The content updater is everything inside this box. It interacts with the outside world down here, these systems, and it interacts with these other containers at the top. And this is just a components inside the system. We go into tweak components. I'm not going to do the whole modularity thing again. Hopefully, if you have a nice modular code base, you get a nice clean one-to-one mapping. So we can jump from the tweak component to see what it looks like in the code. And that's it. That's the diagramming stuff, essentially. So let's talk about tooling. What tools do people here use for drawing diagrams? So we've had Visio and Omnigraffle. What else do you use? PowerPoint. Glyphy, yep. With the Confluence plugin, yep. What about Draw.io, Creately, Sparks Enterprise Architect, Magic Draw, YUML, web sequence diagrams? Take a photo of whiteboard, right? So taking a photo of whiteboard is a great idea, except when you want to change it. Because undoubtedly what will happen is somebody would have rubbed your diagram off and you're like, oh really? Any Graph Viz fans? Yeah, a little bit. So Graph Viz, you kind of feed it a text file with a bunch of stuff in like a graph, and it draws a picture for you and it auto lays out the boxes, which is really nice, but the diagrams suck. So this is a nice question I stole from Quora. And it's like, I want to draw some pictures. I don't want to use UML. That's like the first few words, which is quite funny. I want a cloud, maybe some boxes, some cylinders, and it should look nice. Visio is the simplest answer. So the diagrams I showed you, my own diagrams, drawn in Omnigraffle for the Mac, which is basically Visio. You drag a box onto a canvas, you double click the box, you write some text, you center the text, you make the text bold, change the font size, you add another box, you do the same thing over and over and over again. If you want to draw a line between two boxes, you get a line, you draw it in the right order, you change the arrows, you know, it's just a drawing tool. It's a generic, general purpose drawing tool. And that's why we can use any tool we like to do these diagrams. If you're lucky, you might create a template, so some template for my C4 style diagrams. It's still the same thing. You're dragging a software system off a palette and you're customizing the text and everything else. But it's 2016. Why are we still doing this? The building industry does not use Visio to draw out building blueprints for houses. They use AutoCAD and modeling tools, and they create a nice three-dimensional model, and they surface different views to get the floor plan and the site plan and the elevations and all that stuff. And we build those tools for them. That's the irony here, isn't it? So this is the other thing I want to address. I do not want to recommend Visio anymore. I've been running my sketching architecture workshop for years, and at the end people go, we love your C4 approach. What tools do you recommend? Visio. Really? Whiteboards, pieces of paper, photos of whiteboards work fantastically if you're doing an upfront exercise. What happens about 3, 4, 5 minutes, hours, days after you start writing your first piece of code? Yeah, the diagrams now become out of date. Because you're writing code, you're getting feedback, maybe there were some relationships you didn't flesh out, maybe some responsibilities didn't pan out, so you're breaking things apart. You know, you're iterating over the design. So if somebody has rubbed off your whiteboards, now you're stuck. Code though, why don't we just automatically generate pictures from the code? Because Graphviz makes horrible graphs. Has anybody tried automatically generating a picture from code? What happens? It's garbage. Is that because your system is garbage? Yeah. So you could have the best system in the world, the most beautifully structured system in the world. But if you point these tools at your code base, they're showing you everything. They're showing you your 100,000, 200,000 Java classes, plus all the lines between them. I have a friend, and she was given a project to kind of do an architecture review on, and it was a big code base. So they threw some tooling at the code base. The tooling crashed. So what they did was they built their own tooling. And their tooling worked. But the diagrams were useless because it was just showing everything. And that's one of the things we're trying to do here. So there are lots and lots of tools to do this. IDEs have UML plugins. IDEs know code, and they can normally generate UML diagrams from code. So that's one approach. There are lots of static analysis and dependency analysis tools. Structure 101, Endepend, Lattice, Sonar. But again, they're kind of showing you more, they're focusing on dependencies between things, and they normally give you a very hierarchical view of your code. So top level namespace, double click, next level down, double click, next level down, classes inside. I wouldn't consider those diagrams to be architecture diagrams. They're just visualizing your code for you. This is basically the code gap stuff I talked about yesterday. So although as an architect I want to think about my system as a number of bigger blocks, these diagramming tools, these static analysis tools, they have no idea what a module is, or a layer, or a component. So we either have to teach the tools what a module is, or we have to say, well, okay, I'm going to treat a package as a module because that's all this tool knows how to do. So how do we address the model code gap when we come to automatically generating diagrams? Well, we need to actively fix this problem, not avoid it. And that's one of the things George Fairbanks said in his book. You know, if you ignore this thing, it doesn't go away. It just gets worse. Same thing with that paper I found from the late 90s. It's the, generate a diagram from a code base. It's super accurate. But that's not going to reflect the whiteboard sketch because our models of the world are separate. They're different. So how do we join these two worlds together? That's really what this talk's all about. The model of our system, the modules, the components, the services need to reflect the code. That's really what the whole modular monolith talk was about yesterday. And the abstractions on the diagrams should therefore reflect the code. So if I draw a box on a diagram, it should have some actual real-world reflection in the code somewhere. Otherwise, it's kind of pointless. It's just hurting people's, it's slowing them down. It's putting barriers in the way. What is a component, though? So if I take a code base, what is it I want to draw? The system level context diagram is very easy. The containers diagram is very easy to work out. But once you get down to the component diagram, what is a component in a code base? So I'm going to show you a quick example. Is everybody here? So who here is not a Java developer? A very small number. Great. So in the Java world, there's a framework called Spring. Spring does everything, especially if you talk to the Pubg guys downstairs. Part of Spring, there's a part of Spring called Spring MVC. And Spring MVC lets you or helps you build web MVC model view controller style applications. And the Spring team has a sample application you can download. It's on GitHub. It's called the Spring Pet Clinic. This diagram here on the left is basically the diagram that the Spring team used to summarize this code base from an architecture perspective. There's a bunch of stuff running in the browsers, HTML, CSS essentially, a bit of JavaScript. There's a controller layer with web app controllers. There's a services layer with kind of business logic stuff. And there's a repository layer with data access objects. In the version of you can download, there are actually 3 different repository implementations. When I talk about this application, I delete 2 of them because that's not a real world scenario. So, code into an IDE, you get something like this on the right. So at the top, there's a model package. It's got your domain classes in, your value objects, DTOs, whatever you want to call them. There's a repository package that's got the repositories, these things down here at the bottom. There's a service package, and that's really corresponding to this middle layer. There are utils, because why not? We all have utils. And there's a web package with all of the controllers. So it's just a traditional layered architecture. Imagine I inherit this code base, and I want to automatically draw a picture of this code base to describe it to a colleague. I could automatically generate a UML class diagram to do that. It looks like this. Remember, this is only a small toy code base. It's got like 30 classes, bunch of interfaces. The problem is this diagram is showing you code. It's showing you everything. I promise I did try to move the boxes around so there were no overlapping lines. It's basically impossible. We need to throw some machine learning at this. Or maybe graph is. It's a naive approach, and it definitely doesn't scale if you've got 100,000 classes. Right, so let's step back. Let's take a more considered approach. Instead of showing everything, why don't we focus on showing only those things that have significance from an architecture perspective? And what I mean by this is are they important to the static structure of the system? I'm going to make some assumptions here. I'm going to assume that the model classes, the domain classes, the pet stuff are not structurally significant. We could have an argument afterwards, a debate, but I'm going to make the assumption that they're not important from a structural perspective. I'm going to say that the repositories are important because that was the bottom level on that diagram. The service stuff, the clinic service, as you'll see shortly, is really, really important. I really hope the utils are not significant. That's like a major design smell, but so we're going to exclude the utils. And that the web stuff, the controllers in this case, are significant, again, because that's the top layer. If we take this considered approach, we get that sort of diagram once you dig all the boxes around. Better? We've kind of recreated that layer diagram. We've got controllers along the top. That's the service, and these are my repositories. We can much more clearly see the relationships between these things, but these boxes are still showing code. They're showing classes and they're showing interfaces. If this is like a Google map, this would be something like Street View. It's showing absolutely everything. Imagine if we could zoom up one notch and kind of fly back out to the overhead view of the street and simplify the diagram very, very slightly. Imagine if we could do that, and we could start bundling together the interfaces and classes in this example and recreate those modular boundaries, those component boundaries that we talked about. Imagine if we could do that automatically for this diagram. So this is the same diagram with a different notation. These are the controllers, that's the clinic service, and these are the repositories. And now we've removed some of that code level noise, we can much more clearly see this string of dependencies down here, which may or may not be a good thing, who knows. In the early days of the Agile Manifesto, there was a real big kickback on big upfront design and documentation. And a lot of people said, well, all the information you need is in the code. In fact, you don't even need to write comments because you should write, very reflectful names that describe the intent of the method or the variable. And again, there was a backlash about putting commentary in code because if you put commentary in code, it becomes out of date. The problem is, although that's true to a degree, a code base doesn't tell you everything. Intent is normally missing from a code base, particularly the kind of high-level design decisions that were made once upon a time. Why did we break this application into a web app and a database? That intent's lost in the code. So although the code is the realization of those architectural ideas, it embodies the architecture, it's really hard to reverse that stuff back out of a code base. So is the architecture in the code? Well, no, it's not. There's definitely some stuff in the code, but it needs to be supplemented. When I was doing some research around this, I found a great paper by Paul Clements. He's one of the authors of the Software Architecture and Practice book. And he was talking about architecture description languages. An architecture description language is basically a textual description of normally the static structure of a software system. Is anybody here using them? Anybody here using an architecture description language? That tells you all you need to know. They're not popular. I know about 2 people worldwide using them in the Netherlands for some reason. I don't know why. There are a dozen, maybe 20 different types of architecture description languages if you go look up the Wikipedia page. If you do a search for Darwin architecture description language, that's probably the most popular. You end up at a university website and there's a PDF that you can download and that's the grammar for the language. It's horrendous. There's no way you'll get developers to use a random looking horrible language to describe the structure of a software system. It's not going to work. It's a great idea because text is text, it's versionable. We can check it in, we can diff it. Text has some nice qualities, but it's just a horrible concept. The interesting thing in this paper is that Paul Clements says back in '96, actually we can get architecture from code, it's recoverable. That might have been true in '96, it's not true anymore. I mean, think about how much convention over configuration we see in most apps. It's missing from the code base. You have to supplement all the ideas with a bunch of extra rules. And we can try this out. So imagine we want to create some of my C4 style diagrams for your code base. If you just give me your code base and nothing else, could I ideally automatically extract a list of people, users, roles, personas, actors, from your code base? Probably not. If you were building a web app and you had a configuration file that mapped user types to URLs, I could write some custom code to scrape that file and extract a list of what I thought were user types. But that's not going to apply for everything, and different apps have different security configs. What about the software systems that your system integrates with? Can I get that by looking at your code? Again, same sort of deal. The interaction points between your software system and other people's are not normally explicit. I could do things like look at the class path of your app. If I see Twitter for J, I can make an assumption that your app uses Twitter. I might be wrong, and I don't know why you're using Twitter. I could scrape configuration files and look for known API endpoints. I have to make a bunch of assumptions. What if you're blasting a message on a JMS queue to another system? That's not captured in the code. It's just a push of a message onto a bus. So again, this level of information is hard to get from a code base. If we zoom down, we could ask the same thing about containers. Can I get a list of containers from your code base? And the answer is, well, maybe. If we have an IntelliJ project file, an Eclipse workspace, a Visual Studio Solution file, we could parse that metadata. We could look for web apps. We could look for console apps. We could look for the text public static void main. But again, it's a very cumbersome task, which is error prone. If we zoom down to the next level, can I get a list of components from your code base? Actually, yes. So this is the one level that we potentially can get automatically from a code base. And actually, it's the most interesting level to get from code base because it's the lowest level and therefore it's the most volatile. It changes frequently. The caveat to this, of course, is you need to understand how you identify a component in your code base. And there's not one universal rule to fit them all. And really, this is that whole architecturally evident coding style I talked about yesterday. So if you have a way, a method to identify your components, whether it's through naming conventions or packaging conventions, or you're using annotations, maybe OSGI bundles, whatever, then you can write some code to find those things in your code base using, bog standard static analysis reflection techniques. So that's why I talked about the architecture evident coding style stuff yesterday. I think we should be a bit more conscious about how we structure our code. Naming conventions. I see a lot of teams who have never heard of this stuff, but just by chance they've named everything that's a service with the word service at the end. And they just think that's kind of good practice. So, maybe we need to get more explicit about these sorts of conventions. This is the screenshot I showed you yesterday, and it was for my Tech Tribe's tweets component. And basically, I bundled all of my code into a single package, public interface, package protected implementation classes. This is actually a Spring Bean, so I've also got the Spring configuration tucked away in that package. For the eagle-eyed amongst you, you'll notice there's also an annotation, an @component annotation. And in fact, a couple of people after my keynote asked me, why have you annotated your code? And also, is that the Spring @component annotation? It's not the Spring component annotation, it's my own custom annotation. And the reason I've annotated the code is because machine readable metadata. Adding machine readable metadata to my code, I can now write more codes to go and find that stuff. And that's where it starts to get a bit interesting, because now we have a real way to go and find this tweet component, because I've tagged it. Imagine this scaled up across a big code base. Go find me a list of all these annotated things. Great, now we've got a list of components. So this is why we do need to, again, think more explicitly about how we modularize our... Have a microservices architecture. Identifying microservices is really easy. Spring Boot, Vertex, same thing. So in coming back to describing a software system, what I want to do really is get as much information as I possibly can automatically from a code base, especially down at that lower level. And I want to supplement it with the stuff that's missing, the stuff that's really hard or error prone to get from a code base. And I do like the architecture description language concept. I do want to do this using text and not Visio. So what I've been doing is experimenting, and I've come up with a way to describe the static structure of a software system using code. In this case, just bog standard Java code. So here's some Java for you. And this Java code is a little program, and it's going to create an architecture description of the Spring Pet Clinic system. Boilerplate, ignore that. What this is basically a little Java library. It's all open source, so I'll point you to it in a second. And it implements the C4 approach. And it has a bunch of Java classes representing people, software systems, containers, and components. And there's a little API to kind of wire these things together. So what we do, well, what is the Spring Pet Clinic system? It's a user using the system. That's it. There's no complexity here. So we can just model that with code. Create a software system for the Spring Pet Clinic, create a person, a user, and we can say the user uses the system. Done. Obviously, with a more complex system, you have more lines, but you get the point. We go down to containers. Same thing applies. The Spring Pet Clinic app is basically a web app talking to a relational database. So again, we can just model that with code. Create a container for the web app, create a container for the database. We can then write code to say that the uses the web app uses the database. So we're slowly building up this static structure. We've got the system, now we've got the containers. When I zoom down to components, I don't want to have to do this, because it's going to be really, really tedious. And as I said, actually that's the level I want to extract. So let's just do that. In the open source library, there's this thing called a component finder, and you plug in different strategies. Because the Spring Pet Clinic app is a Spring MVC app, we can create some rules to say, I now know how to go and find my Spring components. And in this case, when you're writing Spring MVC app, you use annotations. You annotate your web app controllers with @controller. You annotate your Spring services with @service. And you annotate your repositories with @repository. So let's use that existing convention, that existing architecturally evident coding style, and let's just use reflection and go find those annotated things. Also built into this Spring Component Finder strategy is some logic that bundles together the interface and the first implementation class it comes across. I'm also going to use my Javadoc Component Finder strategy, and what this does is you point it at the source code and it pulls out the top level Javadoc comment, either for the interface or the class. And I'm going to use that comment to also supplement the model I'm building up. So basically what these 5 lines do is they go find components and the relationships between those components. We can then write some more code to manipulate the model. So this is just some quick Java 8 Lambda stuff, and it basically says, go and find me all of the Spring web app controllers and make the user use them. And go find me all of the Spring repositories and make them use a database. That's it. So now we have a nice in-memory model of a software system. And now we can visualize it with a bunch of views. And again, this is an implementation of the C4 stuff. So essentially, I'm going to create a context view, which is people and systems, a container view, which is people, systems, containers, and I'm going to create a component view for the web app. That's called Structurized for Java. It's all on GitHub. It's all open source. In addition to the Spring stuff, I started working on a Java EE component finder, because again, we can just look for @stateless and whatever. There's a naming convention finder in there, so if you've used a naming convention like star service, you can go and plug that stuff in, and it's all open, so you can add your own component finders. I've got teams in Europe they've added like a Vertex component finder because they're doing microservices and so on and so forth. The thing that's missing is diagrams. And as I said yesterday, I am a sad ass. I do want to see some nice diagrams. Because we have all of this stuff in the model, it's really easy to visualize it. So this is a really super simple JavaScript D3 visualization of the static structure. So my model contains the clinic employee, the user, and the Spring Pet Clinic system. The system contains 2 containers. This container has a bunch of components. Done. Not particularly useful, but again, at least we can see the structure now. Graph is. So based upon those views I created, the context view, the container view, the component view, part of the open source library is a dot file exporter, and all it does is it exports that model into a dot file. You take the dot file, you throw it up to a Graphviz, a tool either locally on the web, automatically generates that picture for you, including the automatic layout. It's ugly, and it doesn't really tell you much, but at least you can see the structure now. You can see, again, the dependencies between the repositories. If you want to get really fancy, you chuck it into a graph database. I mean, this is just a graph that we're building, isn't it? And actually somebody did this. They took my TechTribes graph model, they threw it into Neo4j, and now they can ask it questions with the Cypher language. It's quite powerful, especially on a much larger, bigger project. I still want nice pictures. And I still don't want to use Visio. So this is my vendor alert section. Called Structurizer. This is the thing I mentioned yesterday. There's a free plan and a paid plan, and everything I'm about to show you is more or less doable with the free plan. What you do is you write a little program, like I've just showed you. You scrape information from your system, in this case the Spring Pet Clinic system. The open source library creates a JSON file, a JSON document. Structurizer has an API. You send the JSON document up to Structurizer, and it draws you some diagrams. Caveat time again, you don't have any control whatsoever around the notation the diagram uses. You can change the color, and you can change the size of the font and the size of the box, but that's it. And Structurizer also does not do automatic layouting. So you have to drag boxes around. That's it. That's the only task I'm putting onto you. Drag boxes around. These are the diagrams it gives you for the Spring Pet Clinic system. So this is the context diagram. It's the user using the system. Again, that all came from the code. That's the container diagram. It's the user using the web app using the database. If we zoom in, that's the component diagram I showed you before. So that's all automatically generated by finding components in a code base. Because it's a model, and we can supplement the model with, coloring and stuff and shapes, we can automatically generate keys. This is my #1 bugbear. Whenever I see architecture diagrams that use colors or shapes, they never have a key. Again, we can do that automatically. The other thing I've done is I've hyperlinked the component to the source code. So in this case, if you go to the live diagram on structurizer.com, if you double click, say, the clinic service, you'll get to the clinic service interface on GitHub. So what I've tried to do here is essentially create that set of maps for my code base, where we can go from the high level down to the code. Because diagrams are maps. What I'm trying to do here is create something that looks nice, we can show to people, but it's also useful for me as a developer. I can also do things like dynamic diagrams. So again, we could write some more codes to create a kind of sequence or collaboration style view of the Spring Pet Clinic system. So we can take a feature, a use case, a scenario, we can draft it up in code, and then we can draw a diagram of that. This is not a particularly useful thing to do because you have to write the code programmatically, but imagine you are pushing out diagnostics from your app into a log file or to Splunk, and you can parse and process that stuff to recreate your stack traces if you want to. So again, there's the framework gives you a way to create a dynamic model. How you populate that dynamic model is entirely up to you. Oh yes, this is what happened when I plugged my own tooling into my TechTribes web app. I can explain this, but I shouldn't have to. So it's the same thing. It's a Spring MVC app. These are all of my web app controllers in my TechTribes web app. And these things here are my package by components. So my tweak components lurking around here somewhere. It's showing you all the components, and it's also showing you all of the lines between them. Using a bigger sheet of paper does not make this any better, because you still have too many lines and the lines overlap. So this is a valid question. Does this approach scale? And the answer is no if you use it naively. What we want to do is we we really want to remove some information and not create additional layers of abstraction. So one common way to sort this out is to say, right, I'm going to draw a picture which shows two boxes, a web tier and a bunch of components. So we're kind of grouping our components, and that's not an approach I really like. Because this model is in code, it's in memory, we can simply write more code to slice and dice the model. So what I do in the real tech tribes diagrams is I say, right, instead of showing all of my components on one diagram, I'm going to draw slices through the web app. How do I define a slice? Well, conveniently, all interaction through the web app is via a controller, so let's draw one controller slice at a time. So we write some Java 8 code, we say, go find me all of the Spring controllers and create one component diagram per controller. The net result is essentially you get a larger number of much simpler pictures. So again, we're reducing cognitive load. We're keeping with the same levels of abstraction, but we're showing you an isolated slice through the system. And that works really well. You plug this into your build process, and guess what finally happens? You get up-to-date architecture diagrams that you don't have to draw with Visio. That's the entire point of this. As I said, I'm not trying to sell my structurizer thing. The open source library is all you need to create a model, and you can visualize it in any tooling you want. So you can build your own UIs on top of this if you want to. And really the whole point of this talk is, if your software architecture model is somehow in your code, and this was exactly the point of the keynote, you can get it out again. And if you can get it out, you can draw some nice simple pictures, which are hopefully easy to understand. So that's me done, a couple of minutes early. The wrap-up session is starting at 5:15. Thank you very much once again, and I hope you've had a great couple of days. You certainly may. Certainly may. Hang on,
That good. I like it.
Thank you. Hopefully different enough to yesterday.
It's funny, right? I work for a Dutch company, so I...
Yeah. Dutch and Germans. I don't know why. I'm going to turn this one off now.
Yeah.